Okay, this is the graph of the one we did on the last. Okay, so understand the different ways they're going to call these things. Zeros, roots, solutions, x-intercepts, they all mean pretty much the same thing. It's these values right there. If they were correct about it, they would call it's the zeros of the function, it's the roots of the equation, but they're really sloppy with the way they use those terms. Definitely they're x-intercepts if they cross, and solutions if they cross. Do they always cross the x-axis? Does every parabola cross the x-axis? No. It could be like opening up, but it's already above the middle, or opening down, and it's already below the middle. Does that mean it doesn't have any zeros? No, it just means they're not real numbers. If they show up as crossings of the x-axis, they're real numbers. If they don't, they're imaginary. They still have those. Now, we've already said this zero here was -1/2. This zero here was 3. Okay, so what's the relationship between a zero and a linear factor? How do I make a linear factor from a zero? I'll give you a clue. Here, for this zero here, the linear factor is x minus 3. It's x minus the 0 is the linear factor. Right? Because now, if I plug in 3 to x there, what do I get? 0, okay? That's why. So it's always x minus the 0 is a linear factor. Well, in this case, it's x minus -1/2, which will look like x plus 1/2. Minus a negative makes it a plus. Again, if you plug in -1/2 here, you get 0. Okay. Now, we don't often deal with linear factors that have fractions in them like that. And we didn't do this. This is kind of late to show you this, but in terms of just trying to come up with a polynomial, which could have these two as zeros, you're okay to have multiplied here by 2. If I multiply this thing right there by 2, I get 2x plus 1. Right? You would only use it once. Again, what is the 0 that comes from this factor? It's still -1/2. 2 times -1/2 is -1. -1 plus 1 is 0. So linear factors, if you have that, you can always multiply to get rid of the denominator. It doesn't change the 0. Right? We can't do that in simplifying expressions and things like that. But in terms of linear factors, that works, and then we don't have to deal with the 1/2.